Hey class, I thought to create a video that takes us through to module 11 lab on how to use the Google Colab, the Python Google Colab. So if you go down, you click on this notebook, it opens it up in the Google Colab. So I assume you already logged into your Gmail account, your Google account, and it will pop it up here. Let me expand the window so we can see the whole screen. Now, the nice thing with this, you can make it more accessible by doing Control minus, Control plus. You can zoom in, zoom out, keep it in the font size that is easier for you to access the content. The first thing I want you to do is, before to be able to run this, copy this to your own drive. So we click. It prompts you to log into your Gmail if you haven't logged in already, and it will open it up in your own Google Drive. Now, the nice thing about the Google Colab notebook that I've created is all the content of the lab is already in there. So you don't need to go back to the module and read it. Everything is given to us here. So what we can do is very much look at the content. So this has to do with treating depression. Some feature of this activity might not work on tablets or phones, so I strongly recommend you to use a computer. So what is the context? Where did the data come from? Clinical depression is a recurrent illness requiring treatment and often hospitalization. Nearly 50% of who have an episode of major depression will have a recurrence within 2 to 3 years. Being able to prevent the recurrence of depression in people who have this drug disease would go a long way to alleviate the pain and suffering of patients. During the 1980s, the federal government, through the National Institute of Health, sponsored a large clinical trial to evaluate 2 drugs for depression. There were 3 treatment groups. Patients received either imipramine, lithium, or placebo. Researchers randomly assigned patients to one of the 3 treatment groups and followed them for 2 to 4 years to track any recurrence of depression. This is from a paper published in 1984. So we luckily got access to the raw data that we had collected. What are the variables we have? Hospital, which hospital the patient was from? The labels 1 through 6. Why 1 through 6? Because we want to keep the identity of the patients confidential. What are the treatment? 0 for lithium, 1 imipramine, and 2 for placebo. Outcomes. What does that outcome mean? Hopefully, they had no recurrence of depression. 0 means success, and 1 means a failure. Number of weeks until recurrence. If outcome was 1, that means that it failed, the treatment failed, and they had a recurrence of depression. What was the number of weeks until that recurrence, or until the study end? So if they never got depression, that means the outcome was 0 all the way to the end of the study. How long the patient was depressed before the start of the current study measured in days. Age in years, gender 1 female and 2 male. Unfortunately, the research was done during the time that the gender had a very binary view. We know nowadays the gender that people identify as is more complicated than just 2 binary female and male. But because this was the data we had access to, let's go with that. You can download the data, but you already have it built in. People who use the Art of a Stat, they go on that link and they can download the data. But I designed this in a way that as you run the command in Python, you get the data from GitHub, GitHub that I created for this class. So you see from text, we go to code. So we want to run this code. So this first box, Python is an object-oriented program. That means there are libraries that has a lot of objects that we can bring the object and apply it to the data that we have in this case. So we're going to run this and open a few libraries that contains objects and command needed to complete this lab. Now, this is not a Python programming class, so I'm not going to expect you to understand the pandas in the library, what is the matplot, what is NumPy, what is the matplot library. So that's where it is provided to them. So once we run them, you see this green click. That means you already went through. Now, we want to download the data from GitHub. So I put it on GitHub so anyone around the world can access it. So click here, And when you write the name of the data file, the depression is a CSV file, is a file that we download. If you put .head 11, it gives us the first 11 rows of the data. You want the first 11 because part of this lab, you're going to answer some questions on as a preparation for this measures lab. So this gives you the first 11 rows. You want to increase that, you can. And I strongly suggest you do play with it. So reading a little more. So depression lab has a few parts. So up to this point is a preparation for the lab. So you should be able by running this or increasing this 11, this number 11, let's say you want to do 20. By all means, change that to 20, you can run it, and it gives you the 20 rows. Whatever rows you need, you can answer the question of the preparation. All right, now that brings us to the part one. So if you're watching this for the preparation, pause the video, go complete the preparation lab, and submit it and move on to the next one, which is the treating depression lab part one. So what we're going to do is we're going to analyze the data to answer the first research question. And what is the research question? Which of the drugs, if either, was more successful in preventing the recurrence of depression relative to the placebo? So remember in the previous section, when we prepared, we determined that we're going to analyze the data using a two-way table and conditional percentages. So what we're going to do is here using the Google Colab. So in order to do that, we're going to create a two-way contingency table using, in our case, in this Google Colab notebook. We're going to take a picture of table, embed the image in our discussion board, analyze the data in our two-way table with finding appropriate conditions, conditional percentages. And remember, we're going to look at the efficacy of the drugs. And remember, we're going to write the conditional percentages as a ratio and as a percentage. So it says 25 out of 40, or 25 divided by 40, or we can write it as 0.625 or 62.5%. Then we're going to write a sentence that explains the meaning of percentage in the context of the research question. Based on that, we're going to draw a conclusion. Based on this study, which drug was the most effective in preventing the recurrence of depression? Support the conclusion using conditional percentages. So in order to create a two-way table, you already have the parting command here. So you get the data, so we have the depression treatment. What we wanted to create first is create a cross-tab. So out of that data set, we're going to take the depression data and look at the variable treatment outcome and create a two-way table. And we're going to change the index. So if we just run this first line, it gives us a table of 0, 1, and number of 0 1 we have. Without context is useless. So second line, the index, what it does, it changes the name of the index or the rows, and the next one, it changes the name of the columns. Was it successful or did it fail? And create the total on the table. So let me show you something real quickly. So if you don't run this, so I'm going to change this to, let's see what will happen. So if you don't change those, what we get is a two-way table. You have treatment, you have the outcome. We don't know what 0, 1, 2 stands for. So that's why we created the second line and the third line, because it gives us the context. Now, beautifully, it gives us the name of the row, name of the column. So first one is 0, the second one is the failure, and the total. We're going to use this table to look at the efficacy of the treatment. If a patient received imipramine, given that they received the imipramine, what was the probability of a recurrence of depression? If the patient received a lithium, if it was given that received lithium, what is the probability, what is the proportion, what is the percentage of them having another failure? If it was a placebo, if it is given that in the placebo, what is the probability of recurrence of depression? Now you can switch this question also and look at the success and compare the success. So either way, Either conditional probability should enable you to come to a conclusion. Which of these two treatments, lithium imipramine, are more successful? Now, it would be interesting if a placebo is more successful. That would be a sad story if the treatments were not successful at all. All right, let's continue to the second part of this lab. So the module 9, let me change the viewing on this. So we're going to analyze the data to answer the second research question. Which of the drugs delay the recurrence of depression longer relative to the placebo? So remember to identify treatment as an explanatory variable, as a categorical variable, and time as a response variable. We must see that we've compared the time between these three treatments or comparing them to placebo, which one has the longest delay. So what we're going to do is first we're going to graph and table, use Python or AutoStat, produce graphical description. In this case, we're going to create 3 box plots. We're also going to create descriptive statistics, minimum, maximum, mean, median, standard deviation, interquartile range. We're going to take a picture of our graph, a picture of our descriptive statistic, and embed it into our response to this discussion board. We're going to analyze the data, compare the distributions. So the second part, once we do that, we're going to compare the distribution of the treatment groups as demonstrated in Unity. For example, we're going to compare median, interval of typical values, describe the shape, any outlier, and we want to make sure your comparison is in a way that the context are incorporated into our numbers. So we don't just say the first box plot has statistics significantly lower median than the second one. What does that mean? Put it in the context. Is it placebo? Is it lithium? Is it imipramine? Which treatment we are looking at? And we want you to draw a conclusion. Did one drug successfully delay a relapse of depression better than the others? So, and you're going to summarize your conclusion, make sure you put it in the context of the problem. So to do that, we're going to first create box plots. So within the library Seaborn, there are treatments, there are objects that we can use to create it. Let me close this. What we do is first we create a box plot based on the X variable is going to have treatment and the Y is going to have time, where which data is coming from the data depression that we had earlier in this lab. So let me run this. I also included a strip plot, and what it does, it gives you dot plot. So let me make sure. So what I did was I closed this lab and opened it again, which means I didn't run the previous command. So let me make sure that I run the library one more time. So if you're watching this video, you ran and finish the first part, close all your windows, and you're coming back and nothing is wrong because you haven't ran the previous boxes. So let me run this. These two are important because we get the data. We run the library, we get the data. Now we don't need to run the rest. We can jump to the lab 2. We rerun this one more time, and you see we get the result. We get 0, 1, 2, and remember, 0 is lithium, 1 is imipramine, and 2 placebo. I have it in the notes, so you can compare them. Number of weeks until a recurrence. So which one of them had the longest number of weeks comparing to the other one? I remember between these two, number 2 is the placebo. They didn't get any treatment. Now you want to get this descriptive statistics. So we click on the next one. It creates a group. It creates a group by the treat and the time. So it gives you the treatment and gives you the descriptive statistic. And here you have the mean, a standard deviation, maximum, minimum. And this gives you enough to compare them. You can compare the means, you can compare the median. And remember, median is the 50 percentile, is the half point. Which one of them have the longest or further away from the placebo? Number 2 is the placebo. So which one of those treatments has the longest delay in the recurrence of the depression. So you have enough in this table to be able to answer the questions. Also, you can reference your beautiful box plot that you include. And you see this dot, that's what that strip plot includes. Please come to happy hours if you have any question in this lab. You have our time, it doesn't run for you, it's not a problem. Schedule a happy hours with me. Let's work on it together. All right. As usual, please email me if you have any questions.